Okay, these are going to be the answers to these four problems, these extra four problems. Okay. All right, so Centers for Disease Control report that 22% of 18-year-old women have a body mass of 25 or more, part of a routine check at a large college. We're going to go back to this, so that's important to note. They asked 200 students to self-report their heights and weights. 31 students had a BMI greater than 25. So does that make sense, actually? All right, so first of all, the conditions. Whoops, okay. So the conditions. You always have to do the conditions. So for the rest of these, I'll probably just talk through these quick, but I want you to make sure that you have these written down. So we're going to talk about N times P, 200 times the 22%. That gives us 44. So right here, that 22% is P, 0.22. Okay. The 31 out of 200 right here ends up being P hat, because that's what we're comparing. So that's our P hat, okay? All right, so anyway, N times P is 44, N times Q, 200 times 0.78, because 0.78 is 1 minus the 0.22, and here we get 156. These are both greater than 10, so we are good. So you would explain they're both greater than 10. Success, failure, condition is met. 200 is less than 10% of the population. It does say that it's a large college, so again, you would write that out. 200 is less than 10% of the population. Problem states that it is a large university. It also states that it's random, that the students are randomly selected. So again, if this were a test, you would be explaining these in a little bit more detail. All right, so now let's go through the problem and figure out, is 31 out of 200 unusual? Okay, so we already know what P is, 0.22. P hat is 31 out of 200. Let's figure out what the standard deviation is for the sample. Okay, so the P hat, we're figuring it out for the sample. So make sure that that's why the hat is there. So 0.22 times 0.78 divided by the 200 people that are in the sample. So the standard deviation is 0.029. Normal model works, so we're at 0.22 for our mean and 0.029 for our standard deviation. So we want to find out if this is unusual or not. Normal curve, our mean is 0.22, 0.155 is what this comes out to be. 155. So is that unusual? Okay. All right, so let's figure out the z-score. Z is 0.155 minus 0.22 over 0.029. The z-score is negative 2.241. That's quite a ways away, that it's 2 standard deviations away. So your explanation would be this, and I'm not going to write all this out because I don't have room, so you might want to pause the video. More than 2 standard deviations below the mean of a normal model shows up less than 2.5% of the time. That's because it's 2 standard deviations away. 95% is within that, so 2.5% is in just the one tail. Okay, so more than 2 standard deviations below the mean of a normal model shows up less than 2.5% of the time. Maybe women at this college differ than the general population, or the self-reporting is a problem. So that is the tell that you would do. Okay. All right, next problem. Smoking. It indicates that 26.4% of Americans smoke cigarettes. So P is 26.264. Using this rule, describe the sampling distribution for model for the proportion of smokers among a randomly selected group of 50 adults. So N equals 50. All right, conditions. I'm just going to talk through these. The first one is N times P. Actually, I guess I'll write it down. N times P, so 50 times 0.264. That equals 13.2. N times Q, 50 times 0.736, That equals 36.8. They are both over 10. We are good. Number 2, it says right in the problem they are randomly selected right here. The third condition is the 10%. So 50 is definitely less than 10% of all smokers. All right, so the next thing we need to figure out is the standard deviation of the sample, which is going to be 0.264 times 0.736 divided by 50, and we get 0.062. All right, so our normal model works with a mean of 0.264 and a standard deviation of 0.062. So on my normal curve, this is what you would show. The mean is 0.264. Let's just show one standard deviation on either direction. This is 0.202. This is 0.326. Remember, I just added 0.062 to the proportion for this group. All right. So the way I would explain that is approximate chance of 68% that of smokers that are between 20.2% and 32.6% of 50 people are smokers. So the approximate chance of there's an approximate chance of 68% that between 20.2% and 32.6% of 50 people are smokers. Then you would continue with 95%, 99.7%. Okay? All right. So now we're going to go back to this problem again. It's different here because we're talking about weight. So now we have means. The other one was proportions. Okay? All right. So in this one, our y is 143.74. That's a 7. And our standard deviation for this group is 51.54. Okay. The conditions are the same. Randomized, less than 10% of the college. 200 is going to be large enough so we can use the central limit theorem. So we are good. Okay. So find the standard deviation. Standard deviation for this sample, 51.54 over the square root of 200. This is 3.64. Okay, so in our normal curve, the mean is 143.74. We want to know if 140.1 is unusual, because that's what they tell us. So we should think, oh, I need a z-score. 140.1 minus 143.74. So for this normal curve that's based on the sample, that's why we're using the sample standard deviation here. Okay, is it unusual? Well, my z-score is, why do I not have this written down? Oh, I know. You didn't actually have to figure out the z-score. That's why I didn't write it down. We are about 1 standard deviation away, and I just don't have my calculator in front of me right now. So if you look at this, 3.64, we're a little bit more than 1 standard deviation away. 1 standard deviation away is nothing special. So that's what we would write here. Less than 1 standard deviation, so it's not that unusual. That's all you need to say. Okay? All right. Rainfall. I want to point out definitely with A and C. Okay, so in A, first of all, during what percentage of years does Ithaca get more than 40 inches of rain? Based on this information, okay, based on the information that we have here, what is that? Is it unusual? Or, yeah, during what percentage of years does it get more than 40 inches of rain? So we're going to figure out a z-score. 40 minus 35.4 using this standard deviation because we're not talking about a sample at all. 4.2, my z-score is 1.095. I have too many numbers on my paper here. Now I'm not sure what the answer is. Okay, so I figure out my z-score of 1.095. I don't think I have the answer. I'll have to put that in as a comment. I'm sorry. What percentage of years? So we know what the z-score is. We would actually use the normal model and calculate what percentage that is. Okay. In B, less than how much rain falls in the driest? 20%. My normal model. 20% is here. That's my 20%. So I have to figure out what the z-score is. So I'm going to use the inverse norm in my calculator and figure out that my z-score needs to be negative 0.841. So inverse norm, 20%. 0.2, find out what that area is this. So my z-score is going to be equal to y, because I want to know what that is, minus the mean that we already know and the standard deviation that we know, and I get that y is 51.9. Okay, C. Now we're talking about a sample. Somebody's at school there for 4 years. Mean is the y bar is the mean that this person had while there. All right. So conditions randomized. The 4 years can be considered representative of all the 4 years that the person's there. Number 2, the rainfall is independent, right? Doesn't matter how much it rains 1 year. It doesn't affect the next year. 3, 4 years is, we're going to say that that's less than 10% of all the possible years we can collect data for. And then number 4, the rainfall is normal, so any sample is going to be large enough. It tells us that a normal model applies, okay? All right, so that's done with C. So now in D, we're talking about just the sample. What's the probability that those 4 years average less than 30 inches of rain? Okay, so my normal model, my mean, 35.4, and here's 40. Okay, what's the probability that it's going to be less than that? Okay, oh, 30 inches. Sorry, wrong problem. 30 inches. Okay, so what do I need? I need a z-score. So z equals 30 minus 35.4 divided by the standard deviation for the sample. And that gives me negative 2.571. Okay, so I use my normal CDF and get 0.005 is my answer. Okay, I went through these quickly. Okay, so you might want to watch this over again, but you get the idea. Find a z-score. Is it the standard deviation for the sample or for the population? What are we actually looking at? Okay, all right, there you go. Good luck.